linear and quadratic functions. When plotting straight line graphs of the form y equals mx plus c, and hopefully we'll remember that the m stands for the gradient and the c is the y-intercept, the gradient being how steep the line is, and it tells you for every 1 unit to the right we go, it tells us how many units up or down we go. So if it was a gradient of 3, it would mean for every 1 unit to the right we'd go 3 up. If it was a gradient of -2, it would mean for every unit to the right we go 2 units down. And the intercept, which is the number at the end, it tells us whereabouts on the y-axis it passes through. So there's 3 different methods that we can use to plot lines of the form y equals mx plus c. So we can use the intercept gradient method, a table of values, and we can do a substitution for whenever x equals 0 to work out y, and whenever y is equal to 0 to work out the x value. That'll give us 2 points, and then we can join those up. If we're plotting a quadratic graph, so anything with an x squared in it, we need to use the table of values. And we need to be careful about the maximum or the minimum point to make sure that it's a smooth curve. So in example A, what we have is the line y equals 2x minus 1. And if we think about the first method, which is the intercept gradient, we've got the gradient is 2 and the intercept is -1. So if we look at our graph, we'll mark on some units. So there's 2, 4 and 6 on the y-axis. Again, 2, 4 and 6. -2, -4 and -6 and -2, -4 and -6. So an intercept of -1 means we're going to be crossing the y-axis at this point. The gradient of 2 means that for every 1 unit we go across, we'll go 2 units up. So the next point will be here. And the one after that, 1 unit to the right and 2 up. 1 unit to the right and 2 up. 1 unit to the right and 2 up. And we could also go 1 unit to the left would be 2 down. 1 unit to the left would be 2 down. And what we've got is a nice straight line. So that was using the first method. We could have used the second method, which is the table of values. So for that, we get our x and y. If we substitute in different values, so we could pick -2, 0 and 3, say. And what we do is we substitute those x values into the equation. So that would be y equals 2 times your x value, take away 1. So whenever it's -2, 2 times -2 is -4, take away 1 is -5. When x is 0, 2 zeros are 0, take away 1 is -1. When it's 3, 2 threes are 6, take away 1 is 5. So we have the coordinates -2, -5, which we've already got on our line. 0, -1, which again is on the line. And 3, 5, which again is on the line. So that looks pretty good. And the third value, or the third method, is whenever we've got x equals 0 and y equals 0. So if x equals 0, we've got that y equals 2 times 0 minus 1, which is -1, so we've got the coordinate 0, -1. And then when y is 0, we've got that 0 is going to equal 2x minus 1. So then take the 1 over the other side, we get 1 equals 2x, and dividing by 2 you get 1/2 equals x. So we've got the other coordinate of 1/2 and 0. And if we look at our graph, 1/2, 0, yep, we're there, and 0 minus 1 is there as well. So those are 3 different methods to work out the gradient of the line. Part B then, we've got y equals 3x plus 2. Just want to use a table of values for this way because we normally would do that. So picking different values, we're going to pick -1, 0 and 2. So we're just making any x values and then we work out the corresponding y values. So now we're doing 3 times the -1. So 3 times -1 is -3. Add on 2 is -1. 3 zeros are 0 plus 2 is 2. And 3 2s are 6 and 2 is 8. So if we mark these on our set of x's, 2, 4, 6, 2, 4, 6, minus 2, minus 4, and minus 6, minus 2, minus 4, and minus 6, and 0. So our first point is minus 1, which is here. Then we've got 0, 2. Now our third coordinate, 2, 8, is actually off it. So what you might be tempted to do in an exam is to draw in an extra wee set of boxes and then put the point in there. But try not to do that. So what you should really do then is go back and put in a different point. So if we do 1, so x equals 1, 3 ones are 3, plus 2 is 5. So then we'd have the point 1, 5, which is in here. And if we join those up, we get a nice straight line, and we could extend that down. Example C, if we were going to use our table of values, what we need to do is we'd need to rearrange this into the form y equals mx plus c. So we'd have to do 2y equals minus 3x plus 12, and then divide by 2 to get y equals minus 1.5x plus 6. But that's not that easy, it's a wee bit awkward. So what's actually best to do in this sort of case is to do whenever x equals 0 and work out the corresponding value of y. So we'd have 2y plus 0 equals 12. In other words, that y equals 6. So we've got the point 0, 6. And then whenever y equals 0, we get that 0 plus 3x equals 12. So x equals 4. So then we've got the point 4, 0. So 2, 4, 2, 4, 6. Mark those on, and then join them up with a nice straight line. Example D, what we need to do is it says use brackets on your calculator to work out the values. So how we do that is we get our table of values. So we need to do a table of values for these. And we've given a range of values from minus 3 to 2. So we need to put every single value in that range. So minus 3, minus 2, minus 1, 0, 1, and 2. And to put it into your calculator, we would type 4, take away 2, and then we'll put in a bracket, and it would be minus 3 squared, minus 3 brackets minus 3, and you press equals, and we get minus 5. Then we would replace the minus 3 with minus 2. And put that into your calculator, and we get 2. Then doing the same for minus 1, 0, 1, and 2, we get values of 5, 4, minus 1, and so we can put these on our set of axes. I'm going to change the scales on the x-axis just to make it a little bit nicer. Use up more of our graph. I'm going to keep the scale consistent though, as 1 square is 1 unit on the y-axis. So the first point is minus 3, 5. So it's here. Sorry, minus 5. So we're down here. Then we're at minus 2, 2. And minus 1, 5. 0, 4. 1, minus 1. And 2, that was 10. And it's not on the graph. And then we join them up. A nice smooth curve. And that's what that would look like. Example E then is a non-calculator way to do this. So what we do in a non-calculator way is we separate the equation into its parts. So we've got y is equal to 2x squared. So we've got a 2x squared column. We've got a minus 3x. So we've got minus 3x. And we've got a plus 1. And we've got a plus 1. And then y will equal the sum of those 3 rows. So once we work those out, all we need to do is add these 3 together, and that will work out what y is equal to. Now it's important to remember that 2x squared means 2 multiplied by x squared. So we do the x first. Minus 3x is minus 3 multiplied by the x value, and plus 1 is just 1. So whenever we're filling those in, the 1 is actually the easiest one to do because it's always going to be 1. So we can do that first of all. Minus 3x is minus 3 multiplied by x. So in the first one, we're looking at minus 3 multiplied by minus 2. Two negatives are a positive, and minus 3 times negative 2 will work out to be positive 6. Then minus 3 times minus 1. Two minuses again make a positive, so it's positive 3. Minus 3 times 0, well, anything times 0 is 0. Then minus 3 times 1 is minus 3. Minus 3 times 2 is going to be minus 6. Then minus 9 and minus 12. And what we can see is there's actually a pattern there of taking away 3 each time. Now we said that the 2x squared is 2 multiplied by x squared. So we could think first of all of the x squared values to be 4, 1, 0, 1, 4, 9 and 16. Now the two negative ones, whenever you square a negative, they're positive, so that's why it's 4 and 1. Then 2x squared is going to double all of those, so that's 8, 2, 0, 2, 8, 18 and 32. Then to calculate y, we add the three values together. So 8 plus 6 plus 1, that's going to be 15. 2 add 3 add 1 is 6. 0 and 0 and 1 is 1. 2 take away 3 add 1 is 0. 8 take away 6 add 1 is 3. 18 take away 9 plus 1 is 10. And then 32 take away 12 add 1 is 21. So our coordinates, which are all the x values, so we get minus 2 up to 4, and the corresponding y values 15 to 21. So then we'll have to plot these and then join them up. So minus 2, 15 is plotted here. Minus 1, 6. 0, 1 is the next point. 1, 0. 2 was 3. 3 paired with 10. And 4 was with 21. Then we join these up with a nice smooth curve. Hopefully this will work out. There, so the curve should have gone through all the points and been nice and smooth. Obviously then just be careful that your graph doesn't end up with parts that look like that, or that the line doesn't go through the point. If this was given on a calculator paper, you could use the brackets to input your values. For example, for this equation, you could do 2 brackets, so minus 2 squared, minus 3 times brackets, minus 2 plus 1, and that would work out the x values every time.